Working in section 3.2, we have does seat location affect grades? Many people believe that students learn better if they sit closer to the front of the classroom. Does sitting closer cause higher achievement, or do better students simply choose to sit in the front? To investigate, an AP Statistics teacher randomly assigned students to seat locations in his classroom for a particular chapter. At the end of the chapter, he recorded the row number, row 1 is closest to the front, and test score for each student. Least squares regression was performed on the data, a scatter plot with the regression line added, a residual plot, and some computer output from the regression are shown below. So before we get into that, just want you to think about the situation that we're being asked to investigate. Now, if this is the case where sitting closer helps your achievement, then that would mean the lower your row number, the higher your test score is. So remember, one variable going down while the other variable goes up would mean a negative correlation. So if we thought about that and pair that together with the idea of, if that's really true, then that should mean for every row I move closer, I have a set amount of points I should get back on a test. So for instance, for every row I move closer, I would have 10 points higher on my test score. If it was that simple, we would all just move up, but that's the idea behind it. And as soon as you start talking about something like that, that means you would have a slope to a line. So we should be anticipating having points that are linear in nature and a negative relationship. Here's what the data actually looks like and the computer output that they are referring to. Now we can see that a least squares regression line was drawn through it. It definitely has a negative slope to it. But if there's a relationship here, it's extremely weak. There is a mostly scattering of points, although there might be somewhat of a general direction to them. In our residuals, we see a nice scattering there, so it does confirm that a linear model would be appropriate. And then we have our computer output. This is going to look very foreign to you in the beginning. Get used to it though. Try to get comfortable with it. Try to understand it because you're going to see this very often. You're going to get computer output a lot. So I'm going to help you kind of make sense of it. I'll start off with our problem here. What is the equation of the least squares regression line that describes the relationship between row number and test score? Define any variables that you use. So think about the fact that we're going to write the equation of a line. And think back to your y equals mx plus b days. Now here in stats so far we've been using y hat equals a plus bx because that's what we see in our resource packet. We'll grab that real quick. So we have here y hat equals b naught plus b1x. So same idea. You can write it either way, it is perfectly fine, but just reminding you of what we've done so far. So we have our slope, our y-intercept. In either case, remember our y-intercept is always our constant value. So when you come over here to look at your computer output, you're looking for your constant value to give you your y-intercept. Then we have our slope, and in either case, our slope is always our coefficient to our variable. Now remember, in this case, our variable stood for our row. So we want to look at the coefficient to the row. And that is where our slope is going to come from. The rest of this mess that you're seeing right now, ignore. If all we're worrying about is writing the equation of our line, we need a constant and a coefficient, a y-intercept and a slope. So, sorry, let me move that so you can see it. The equation is y hat equals 85.706, notice coming from there, minus 1.1171x, again coming from there, and I know it's kind of hard to see with my pink over it, but there was the negative there, where y hat equals the predicted test score and x equals the row number. make sure you're defining these variables. That's a key thing, something that's going to come up a lot in the scoring of tests. Part B, interpret the slope of the regression line in context. So our slope is negative 1.1171x, and again, think back to your Algebra 1 days. Slope is rise over run. It is your change in y over your change in x. Okay, that notation is a little bit more sophisticated than you probably saw in Algebra 1, but same idea. Change in y over change in x. As my test scores increase, what happens to my row? Or as my rows increase or decrease, what happens to my test score? So I can use that for my interpretation. For each additional row from the front of the classroom, the least squares regression line predicts a decrease of 1.1171 points on the student's test score. So in other words, for every row I move back in class, I would be scoring about 1 point less on the test. Part C asks us to find the correlation. Again, we do not need to do this by hand. It's all given to us right here. We just have to be able to locate it. So for our correlation, remember correlation is our R. We're looking for what R equals. If you look up here, you don't see anything that what R equals, but you do see what R squared equals. So we know that R squared is equal to 4.7% or 0.047. Then to get R, we would just take the square root of that. You don't have to write that out in words, but you will need to calculate that out, and you get that it's negative 0.217. Now you're probably looking at this and saying, but there is no negative there. Where did the negative suddenly come from? And that's where we have to think back to what correlation actually is. Correlation tells us our direction as well. So since this is in a negative direction, we have to attach that negative value to our correlation. And then finally, is align an appropriate model to use for these data. Explain how you know. I referred to that in the very beginning when we started. So because there is no obvious leftover pattern in the residual plot, align is an appropriate model for these data. Again, notice I've done very little work here. You can see on this paper how much work is shown. It's very little. It was just a matter of being able to interpret what was given to me. So understanding what you've already been given.